So good afternoon, everybody.
Hey,
This is the fourth of the BuildOn sessions, and today I'm going to talk a little bit about my solution to DIRNav, and I'll talk about some design ideas for the command line processor, and then we'll talk about Rust iterators. And we'll talk about writing idiomatic code in Rust. What does that mean and how can you do it? And yeah, so that's the idea. Okay, so here we are on step 3 in session 4. Main focus is command line parser. And let's start by taking a look at my DIRNav code. And by the way, clicking on this BuildOn will takes you here, and you can go by clicking on this upper link. You can go to the code. We'll come back and look at it again in a minute. So. So here's my DIRNav solution. Let's just quickly run it. And it's just, starting out on one directory above the project folder, and you can see. By the way, this is Windows, and normally the Windows separator is two forward slashes or backward slashes or whatever, and they annoy me, so I change them to the Linux and Mac, the forward slash format. So that's why they're that way. If I ran it on Linux, you'd see it, without me doing anything, you'd see them that way. But anyway, so DIRNav is DIRNav is templatized or is parameterized on an app that implements the dir event trait. And the dir event trait, the main important part is do dir and do file. So every time Directory Navigator finds a do dir, finds a directory, enters a directory, it calls do dir. Every time it finds a file, it calls do file. And I've designed this so that when I enter a directory, the first thing I do is look for all the files, and I just any directories I find, I just push onto a little queue. And then once I've found all the files and called do file on all the files, and then I'll go down into the child directories, and that makes it easy to keep, make sure that the files are associated, that the file is associated with the correct directory. So I'm using this triple, slash comment. And these support documentations, just like Java Docs, works the same way. And I don't much like it, just like I don't much like Java Docs, because it makes the code harder to read. But it generates beautiful documentation. I'm going to show you that in just a minute or two. But anyway, so I've got this DIRNav, and above I just defined a little. No, I did that. I defined a mock uh, app taking the place, it's mocking the text search in the test file. So here's my, I have a, I've defined a type search patterns, an alias search patterns for a vec of path buffs. I am using, I've kind of converted to using paths and path buffs for any place I use a path string. It's just easier. You do less conversions if you do it that way. And so I'm using path buff, which is path buff corresponds to string, and path corresponds to str. You know, one is a own, you know, a type that owns detail on the heap, and the other is a totally local, you know, stack frame based thing. I have a vector of search patterns. This is my app. Whatever this guy is, I'm composing with one of him. I don't know what it is, and I don't care. As long as he implements the dodir, I don't care. And then a couple of, you know, I'm keeping track of how many files and how many directories I've recursed and whether I'm going to recurse or not. So what I'm doing is pushing all of the application-specific stuff from dirnav into the app that I can, but there's things like the search patterns. I don't want to push that, even though that's application-specific. I don't want to push that into the app because using a search pattern will eliminate me looking at a whole bunch of files. I don't want to look at a whole bunch of files and then ignore them in the application. So I'm managing the file patterns, and I'm managing whether I'm going to recurse or not in this. But everything else is pushed off into all the other application-specific stuff is pushed off into the app. And here I'm implementing the app, and here I am bounding it. I'm constraining it to implement the dir event and a default, just so that it's easy for users to initialize it. And then, you know, here's my here's my constructor new, which returns self. And again, my app is constrained by dir event and default. And I need to, it's a quirk of the way Rust syntax checking works that even though you put it up here in the impl, you still have to, you'll still have to display it down here. Okay.
Doc, is that true of any method you write? Do you have to constrain it that way if you want to ensure it?
Yeah, any generic method.
Okay, yeah.
Just generic methods, okay? But here, you know, these are all generic because they're part of this generic app, generic type. Okay, and then I have a bunch of, you know, recurse. I can set that parameter that tells it do recurse or don't recurse. In the next, not command line, but the next one after that, when we put everything together, the executive has got to get at the app because the app is text search and the executive needs to give him text. I'm having dirnav create an instance of the app right here, okay? So, and I don't want dirnav to have to know the search text. So what I'm doing is letting the executive just go to dirnav and say, give me access to, give me a reference to your app so that I can give him the text, search text. And then, you know, I'm making available the number of directories I processed and files I processed. And, you know, you can get at the patterns if you want to add one in midstream or something like that. I'm not doing that, but, and you can clear everything. This clears the entire state of dirnav. And the important thing is the visit function. This is the guy that you're going to call recursively. And notice that he puts out an IO result because we're interacting with the file system, and the file system returns these IO results. If you remember, the result is an enumeration that has OK and error, and so it's parameterized on two types, but the IO subsystem has defined type result with one argument, result of t, as equal to IO as equal to result of t and e. So it's just the idea here is simply that all of your errors are going to be IO errors, and so why keep repeating that again and again and again? That's why they did that. So now here, when I enter this visit, the first thing I do is I tell my application I just entered this directory. And then now I'm going to keep in a vector of path buffs all the subdirectories I encounter, because I want to find all the files, and I can't count on the files coming first. There's very likely to be a mix of directories and subdirectories and paths, whatever scheme the file system used to record them. So when I find a directory, I'm just going to push it onto here. So this thing I just entered had darn well be a directory. If it isn't, then I'm going to exit, but because that's an error. But otherwise, now I'm going to read the directory, this thing I'm in. I'm going to read the directory for entries. And what that means is files and subdirectories and all their metadata. That's what I'm reading. And so here, entry now is a standard result, and I don't want to handle that error here. I just say let entry equal this entry, the standard result, question mark. And I'm bubbling up the error. What the question mark does is, if there's no error, it just binds this result part, the result part of this, which is the dir entry. Here's my result. It just binds this dir entry to entry. If there is an error, then it returns, and the error comes out here as an output of this function. That's the way this works. Really nice, makes the error handling really simple, and So now I grab the path of that entry. If it's a dir, I push it onto the subdirectories. If it's not a dir, then I see, are you in my patterns? Or if the patterns is empty, I'm going to show all of them. Instead of showing none, if the patterns is empty, I'll show all the files. Just a convenient default. That's all. That's the model. So make it easy for the user. And then I just say self app.doFile. Now I'm telling my app, here comes a file I found that matches the patterns that we need to match. And what I'm passing is the file name. I don't pass them the entry, I just pass them the file name. And now for sub and subdirs, so now having found all the files, okay, here is my complete iteration through that directory. Now, having found all the subdirectories, I just iterate through them, calling visit. Piece of cake. Return OK, and so on. And then there's a bunch of, there's a helper function in patterns, to check, is this file in the patterns, which I'm using right here. Whoops, right here. And here's my replace separator. Here's where I'm changing the Windows separators into a Linux separator, because it's a little easier to read. And then there's a bunch of tests, and if you remember from the last time, we said that these tests are they're designed to trigger assertions. So here I'm just, what I'm doing here is defining my app, an app test for all my tests. And then I just, I create some directories. And now, so I've set up all my tests. And now I just walk through my tests. And what the tests expect to do is fire off asserts. By default, even if you write to the console, you won't see it as you run the tests. And you run tests like this. I just ran the tests. Okay. Okay. But the usual, so once you've got those, low-level stuff, what you'll normally do is you'll create in a directory called examples. So the library is in source, and in a sister directory called examples, you put whatever, anything in here has a main, and if you name it, that's what you run, and what this does, when you name it, it builds, it takes this and links it to the library, and now you have a running test for your library, and you can have as many of these as you want. You can have 3 or 4 or 5 or 6, whatever you want for your library. And you just run that by saying cargo run example. Here's a quirk. This directory is examples in the plural, but you got to say example in the singular, test1, and you can't put the extension on it. You got to leave it that way or it won't work. And then it runs it. So that's cargo. That's dirnav. I want to do 2 more things. We're going to talk a little later on about writing idiomatic code. Let's do this. Cargo Clippy. And what Clippy just told me is that as far as he can tell, I'm totally idiomatic. No warnings were emitted. Now, I'm going to show you in my command line parser, it's going to generate a whole bunch of errors because I didn't go through it and remove the Clippy stuff. I'm going to tell you that it was because I wanted to demonstrate it. That really isn't true. I just didn't get around to it. But and then usually when I write stuff, Clippy will find a few things and I'll go fix them and satisfy Clippy. Every once in a while, you disagree with Clippy, and there's a little declaration you can provide that says, ignore Clippy, don't give me this warning. I don't want it. It's just like in Windows, you have the pragma, whatever. So the other thing I want to demonstrate is doc.
Professor, a quick question.
Yeah.
Is that what the dead code line means? Is that for Clippy?
I'm sorry?
In the dir, I think that's in the lib.rs file, where you have the dir nav code. I think right above the implementation. Yeah, right here. Maybe can you scroll down?
This is warnings. I guess that's a Clippy warning. I don't think it's a Clippy warning. I think that's a compiler warning.
Okay.
To avoid Clippy warnings, what you say is allow Clippy : in the name of Clippy's warning.
Okay.
Okay. But good question. So now I want to run doc, but I want to run it this way. Cargo doc. Document private items. Hang on 1 minute. Let me find my PDF, wherever my PDF went. Document private items. Yep. So Now, let's come down into target. Now I've got this directory called doc. It wasn't there before I ran doc. And now, if I go into dirnav, here's all that HTML. So let me pull this up. And what I want is, I don't want what I just did. What I want is, let me go to, I am in SU, temp, BuildOn 4, BuildOn private, BuildOn solutions, dirnav, target. Can you see? Can you guys see this this window?
Yes.
Okay. So now I want dirnav, and now I'm going to pull up all. Now here is the documentation for my dirnav. So show declaration. Here's my dirnav declaration with all its parts. And then all of the functions I've defined are over here in the left pane. Can you guys all see that? Is it clear enough? And then my comments, file extension or process, this came from the triple backslashes. I get these guys from those backslashes, you know. And it's really good. You know, here's my impl of dirnav, and so pub new, you know, and recursive visits are recursive, get app, return reference to app to configure, get results. So you can put comments that go along with all your documentation. It's there, you know, and so, you know, and here, this is just the way the standard library is documented, and the Rust facilities. It's just using this. They've given you access to their tools for generating documentation. It's really cool. So, okay. So let's go back to this, and let's go back to this. So now I've been in this, you know, dirnav. Now I want to look a little bit at my command line, not to show you the code. I'm not gonna. But I want to run it and talk a little bit about the design process. So, so now, cargo. So this is command line. This is my solution to command line that I'm going to run. And I just want to use it to talk a little bit about some of the design ideas. So cargo run example test 2. So here I have I have two different test files. They both have mains. And now this is just going to link, this command will link this to test 2. And let me give it some command line parameters. /p is what I use for paths, /p for patterns, /t for text. So let's search for struct. And I'm going to add a couple more patterns, p, h, cpp. And the idea here is that the way I designed the parser, it ignores everything on the command line until it hits an argument that starts with a backslash or / or whatever that is. And when it is, it says this thing is an attribute. And if I add some more stuff to it, let's add something else to it right here. If I could type.
Doc, I'm going to step out at this point. The guys are getting started here, so I'll catch up with you shortly. Thanks for
Okay,
everything.
good. Yep.
Okay.
So now, what's going on here is when I hit a backslash, this is an attribute. Every argument that follows is a value for that attribute. And what I'm doing is I'm storing these in a hash map of string and vec of string. I just happen to be using the first character, but I could use more of that if I wanted to, and I'll talk about that in just a minute. But anyway, so if I have two separate arguments, I notice that this will pass okay because the first character is not a backslash. I hope it will. I haven't tested this, so we'll see. But anyway, and now here I have backslash p rs, so that puts into the pattern, for the pattern. And the command line parser doesn't know anything about the meaning of these attributes. It just knows that it has a key and some values associated with that key. And, t-struct, and now p, it adds two more. So let's just run it. So now we can see, I'm showing you what command line parser looks like here. And here's P, the patterns. It has RS, H, and CPP. It just keeps adding them in. You can have that little P attribute as many times as you want, and it'll just keep adding in values to the first one. And here's the path, and thank goodness it worked. So I'm just looking for the first character as being a backslash, and everything else it's just a string. And here's my struct. So it's really convenient and easy to use, and it's also really easy to implement. Okay, so and I'm listing out the command line arguments, and and here is a condensed version. I have a function command line parse that shows you what you parsed, and here's the little the patterns, and here's the paths, and here's the text, and command line parser doesn't know, for example, my TextFinder only uses the first entry in the path section. And command line parser doesn't care. It'll, whatever you put on the command line, it'll give you, and then your program can do whatever it wants to with it. So there's really two parts. One part is to develop this reusable parsing, command line parsing facility. And the other is, and it turns out it's pretty simple, the other part is to build in your application stuff that sets default values for parameters it's interested in. So what I do is I have a way of entering keys and values in that hash table. So here, for example, I've commented them out, but here is a CP insert, and there's a key and a value. And so the idea here is that the user, you allow your users, if they're happy with the default, they don't have to enter anything. And your program will come along, and for that parameter, like a path, my file finder, if I don't enter a path, it gives me dot. And it does that because my application specific side comes and looks at my hash table, and it says it doesn't have a P, so I'll put in the default, I'll put in P and the default value. But if it had a path, I don't do anything. So it's just a nice way of, getting this, letting the user enter the least amount possible and still work effectively. Make sense, Nooper? Maybe.
Yes.
Okay. You look like you weren't quite certain about that.
I am thinking where you are adding the default.
I'm adding that. I'm not doing it in here, and I'm not going to show you. Okay. So I chose not to give you any starter code this time. My model is that you've had a little practice. Now it's time to take off the training wheels and let you go. Okay. So, but you'll find it's not very hard to do. We're really just building a little wrapper around a hash map. And I've given you, you've seen lots of my code for hash maps. And the only thing we do, in this helper is I've got a function that just uses these inserts. And so for all the parameters, all the attributes that my program is going to use, I have default values for that, and I call insert with those parameters. But if there's something already there, it doesn't insert. It only inserts if there's nothing there, because I don't want to overwrite something that the user entered on the command line. I just want to provide a default if he didn't provide anything. I probably should have called that if empty insert. That would have been, maybe I'll go back and change that because it really should be. But anyway, that's the model for Parser. Okay. You don't have to use it, You could meet the specifications some other way, but this is really simple, easy to implement, and it has really nice user ergonomics. Okay, it's really easy for the user to they can just call TextFinder and it'll run. Almost always they would enter some text, but a lot of times when I use it, the only thing I enter is the text, T/ whatever text I'm looking for. Okay, any questions before we leave that?
Professor, I had a query here.
Yeah.
Why are we having two separate P keys, and why aren't we merging it into a single one?
Could you use here? Let me turn up my volume. I didn't hear. Okay, try it again.
Sure. So over here we have two separate P keys, right?
Two separate. Oh, this is a lowercase p for file pattern. This is an uppercase P for paths.
Okay.
Okay. So this is case sensitive.
Okay.
Now I did in my I'll give you a quick little peek, not much, but a quick little peek. I did make my hash table of vec of string, so I could have used a string here. All my processing is going to do, the way I designed it, is look at the first character. But I could have put in a string, But anyway, it's case sensitive. That's the deal. All right. Are we now? Yeah. So now I want to run Clippy. Let's see what happens. Cargo Clippy. Oh, Clippy isn't too happy with me. Let's see what he's complaining about. Now, understand there's a perfectly correct program doing exactly what I want, and there really are as far as I know, no defects. But let's look at what Clippy is telling us about. There's 11 warnings it's complaining about. It says I should add a default implementation for command line parser, and I have one here. This is essentially a weakness of the rule processing, because I do have, if I can figure out where I put it, where's my lib? Oh, no, where's my lib? Well, I lost my library. I lost my edit window is what I lost. Well, I don't know. But anyway, um, when I'm done with this, I'll come back. We'll come back and get it back, and I'll talk about it a little bit. I really have a default that I'm implementing indirectly. Now, here's a place. This is perfectly correct. If self.args.len equals 0, and he's saying, hey, there's an isEmpty function. It's clearer and more explicit, and I agree. I just didn't remember there was an isEmpty function. You know, there's so much stuff, so many facilities in the language and libraries that you can't remember all that stuff. But Clippy has a really long memory. Okay, so it's telling you about it. So now, one of the things you want to avoid is doing, use what's there. So here, I would just change this to isEmpty, and Clippy, that message would go away. And 3 or 4 of these messages are all the isEmpty. Here's another place. So if let sum iter equals nth of 0, I'm looking for the first character in that string. And Clippy is saying, hey, just use next. It means the same thing. What's going on here is this is not giving me the first item in my collection. This is giving me the first item and what remains in the iterator. What happens is the iterator runs, the earlier items, it loses those earlier items. It's just keeping what's left. And so nth of 0 and next mean exactly the same thing. So it's just telling me use next. And that's what a lot of these are. Now here's one. Statement can be reduced. He's telling me this is more complicated than it needs to be. And this is something, these I would just quickly go and follow Clippy's instruction, bang, bang, I'm done. Here, I want to look at this and see what is it that I'm doing that, why is Clippy's suggested way of doing this better? And almost always he gives you a he didn't in this case. It just says it can be reduced. So he's telling me to go look at it. But anyway, so this is telling me there's a shortcoming in what you know about Rust. It's great for especially for people that are beginning. It's great to have Clippy holler at you because he's telling you about things. Gee, you ought to know about this. Go look at it. Really, really, really nice. Okay, I use Clippy a lot. So it's just telling me I can make this simpler and reduce it. Return, so the normal Rust model is that you don't use a return statement. You just, the last statement in a block, in a scope, if you don't put a semicolon after it to make it a statement, it's an expression. That expression value is returned by the block. And so that's the standard way of doing it. Now, I happen to be returning from the middle, and I thought it was clearer to have the return statement. And so here's a place where I would put a declaration, pound colon bracket, allow Clippy colon, and needless return. See here this? all I'm doing really is taking this statement and changing the warn into allow and putting it at the top of my code, and that'll stop that error. Okay, so, you know, and so there's a bunch of these. Some of them are, you know, stylistic, and that, you know, that's important. That says, hey, you're not being idiomatic. Some of these are saying you're doing things kind of, you know, in a way that's a little more complicated than it needs to be, and that's great because it helps you learn the language. So anyway, so that's Clippy.
Prof-
Yeah.
Professor, is there any performance impact of, you know, like say whatever the suggestions are being made by clipping?
Yeah, I'm going to talk about that later on. In other words, Clippy will tell you when it can figure out that you're doing something that might not be the best performance-wise. It will tell you. It's not perfect. It doesn't know everything. You know, there's a lot of stuff. It can't look at some complicated big piece of code and analyze it and lay on it, you know, Rust facilities on it. It can't do that. But what it can do is look at what you've done and say, hey, for example, here in one of my statements, I had a clone, and you try not to use clone. That just means I'm making a copy right here. That's because this happens to take a self argument and would eat this attribute. And I don't want that attribute to become invalid, and so I cloned it. And there's probably a way I could, you know, I could probably just enter a reference or something like that. But anyway, you know, it's something for me to look at a little bit. All right, so now let me see if I can figure out how to get my, yeah, here we go. Here it is. So, and there was something I was going to, I guess I already did. Okay, so let's go back. Are there any questions about what we've done so far? Notice here I'm not using all those triple slash comments. I don't like them. They make code hard to read for me. My practice would be something that I want to publish on Crates.io or something like that. I would put all them in so that Crates could generate documentation for it. Or I might build a little Rust tool that would add in, you know, every place I have a double backslash, it would turn it into a triple backslash, and then go back later on and remove them, you know, something like that. I don't know, but anyway, a lot of nice facilities. So with that, let's see where we are. So we talked about the design ideas and we ran the parser. We talked about the fact that you could make this a char and a vector of strings, and that would be a performance improvement, Mikhail. But here, I'm not at all worried about performance on this parser because you're going to run it once in your program when you begin, and it just has to run at human speed. So of all the places that I wouldn't look for performance, this is the top on the list. Lots of places you want to look for it, you want to, you know, pay very careful attention. So in upshot, I see this as there being two parts. The biggest part is what you've just seen me exercising, the reusable parser. And then the next is just a simple little function that goes and installs, you know, that recognizes all of the parameters your program is going to use and installs default values if they're not already in what was parsed for the command line. So, okay, so if we're ready, let's quickly, I'm going to click on this, BuildOn. This takes you to the GitHub, you know, BuildOn thing. And here's my BuildOn 2 solution, a text search. Here's my DirNav solution. And, you know, next time we meet, there'll be a BuildOn 4 solution, my Parser will be here. So you can get access to all of them just by coming to this. It's always up here in this corner. So this is a repository documentation for the BuildOn repository, and getting to the actual code from the documentation is always a matter of clicking on this upper right link. And I just list the, TextFinder. These are the various BuildOn things. So for example, for the command line parser, there's this, and I talk about its operation a little bit, and I provide a specification for the command line parser, and then no starter code, a little message that, hey, not gonna be any starter code, and then some references. So, and you can get back, you can navigate around this way. So now what I want to do is, let's go look at iterators. I didn't make that. It's clickable over here. So I want to talk about iteration in Rust. Rust has a really nice facility done, and a lot of Rust is really clever ideas. They've taken essentially the C++ execution model and laid onto that a whole bunch of really clever ideas. So the move, transferring identity with moves, always, instead of only under special circumstances like C++ when so anyway, Rust iterator is something that provides a function next, this takes a reference to self. So this says that the iterator that I am calling next on will not be consumed. Okay, because I'm using a reference to self. If this was self, then it would be a consuming iterator, and once I'd used it, it was gone. And what it does is it returns an option. So this option is either some of the item, or the item might be a reference to usually is a reference to the underlying item in the collection. But for some iterators, it's the value. Okay, so here, if I return it by reference, then I'm not transferring ownership. If I transfer it by value, then I am transferring ownership, out of that container, out of that collection, and that'll destroy the collection. And I'll talk a little bit more here about that. So with most things, you're going to use this iterator trait, and that normally you get to by calling a function iter. We'll see that below, in a table below. And that just lets you step through collections. And what happens is you keep getting some with different items here, but eventually when you get to the end of the collection, it'll return none, saying I don't have any more elements for you. You can't reset the iterator. It would be nice if you could, but you can't reset the iterator. It just you can just declare another iterator. It works just fine. Okay, not much harder. But now there's another way to get an iterator. So this with this, any collection that implements the iterator trait, you just call the instance name of that collection dot iter, iter, empty parens, and that'll give you an iterator. But some things implement into iterator, and what this says is the collection is saying, I will turn myself into an iterator for you, but now the collection is gone. This is a consuming operation. Notice that this isn't a reference to self, this is self. So that says I'm consuming. And the reason for that is something like an array you can't pass out arrays are a little funny. You can't move out a particular element of the array. So I'll come back to that because I got some examples. But anyway, a lot of collections provide this into Iterator, and this just says, if you don't need me, you know, I can hand you an iterator. This is the iterator. I can hand you an iterator that I built out of myself, losing myself in the process, and then you just sit and use it. And we'll see how to do that. Here I have a couple of functions that implement iterators, just so you know how to pass an iterator to a function. So here, do iter, I'm passing in an iterator, and here I'm saying t is an iterator. So this is a I'm saying do iterator over t, where t is this iterator. So t has to implement the iterator property, and the item, because I'm going to print it out, has to implement the debug property. And this shows you, you know, here's how, if I've got a type t, and iterators always have an associated item. This is an associated item with the iterators, and I'll show you in a little bit, I'll show you exactly how that syntax works. But anyway, so, you know, I'm passing an iterator in and using it, and here I'm passing an iterator, I'm passing using into iterator. Here I pass by reference, here I'm passing by value into iterator, and now this is a consuming operation. And here I'm just using the iterator directly, and here I'm using a for loop, and I'm going to show you in the upcoming, you know, in the rest of this presentation that a for loop is just a little bit of syntax wrapper around this kind of loop. Okay, so iter does not consume a collection, into iter does. So let's look at, here is playground, and so I've got a type checker. And so here I'm running, I'm declaring a vector v and displaying it. And here, you know, for item v in v.iter, so I'm just getting an iterator for v, I display it. Okay, and now I'm going to use v again, and that, you know, this proves, because I didn't have to, because this builds, that this guy didn't get consumed. Okay, I didn't transfer his ownership anywhere else by this operation, and you don't with an iter. So now I'm going to say for item in v.into iter, and now I'm consuming v and using it, and that's what's happening in the second line here. And now this code fails to compile. So let me uncomment it. This will fail to compile because I'm trying to use v, and I've already consumed it. So it's nicely telling me, hey, this is a move type. Here's where you moved it, and here's where you're trying to use it after you've moved it. Okay, so the error message in Rust are just phenomenal. They tell you exactly what's going on. Here I'm building a vector of strings. Here I'm using the nth zero that Clippy gets unhappy about. And let me run this again. So, you know, I display the type, and then I'm displaying the element, and then I'm displaying the type of the element. So the first element is a 1, and it has the type reference to string. Okay, the 1 is this one right here. let's do this. And now you'll see the question mark because I'm using the debug format. You see the question. It is really a string and it has a type reference to string. And now when I am iterating here from into iter, so this says V, turn yourself into an iterator, and I'm not going to return a reference to my elements. I'm going to return the element itself. I'm going to transfer ownership from the option to you. And that's what I just did here. So now this has type string. I'm an owner of that string now. And my original vector is gone because I used into iter. There are places where you want to use it. There's places where you have to use it, just because of the type of data you're processing. But nice to know how that works. Okay. Here's a nice little, a guy by the name of Matt Brubeck is a developer on the Rust team, or was, I don't know if he still is. And he did this really nice post. Here he's showing you how to return, suppose I have a type, struct, my struct, and my item is a vector of strings. I can return an iterator from that as if it was my own, I just say impl my struct function string. So my name, to get that, instead of saying iter, you'll say the instance of my struct dot strings, and it's going to return an iterator into this vector collection. And you can run it. So cool. And this is what you'd normally do when if you want to provide your clients, your users, the ability to iterate over your own type, you just return an iterator from that existing underlying collection. But here he's showing you, I'm not going to take the time to walk you through this, but he's showing you how you can implement your own iterator. And you might want to take a look at this because you get a little more comfortable, a little better idea of how these iterators work. One of the issues here is you'll see this tick A. Remember that tick A is a lifetime. And when you're, so he's returning a custom iterator object. See, here's his struct, and he's going to return an instance of this type, and the compiler wants to know, is this iterator type going to live longer than the struct? And so he lost what he's trying to iterate over, and this lifetime convinces the compiler that won't happen. It gives the compiler a way to check it to make sure that it doesn't happen. If your code lets that happen, then the compiler, it won't build. Okay, so iterating over collections. So most of the collections provide either iter, which iterates over references to T, or itermute, which iterates over a mutable reference to T, so you can change it from that, from that iteration. And here, so what I'm showing you here is this is the iter function is returning this object, which is an iterator. That's really what's happening. Okay, so if you remember from that last playground example, you saw me call v.iter parens dot some stuff, and what I'm doing is just using the iterator, calling next on this iterator right here. Itermute returns a mutable iterator, and I have an option to mute reference of T. And now for the consuming iterator, iterates over and consumes T because it takes self. It returns this into iterator, and that has a function next self that returns an option to the value. Almost always you're going to use these, but every once in a while, you need to know about this. And So here I'm just, let me run it. I am using my type function to ask what the type is of these various iterators. So here I create a vector, and now I'm passing in a reference to v.iter, and it's telling me its type is core slice iter I32. And of course it's I32, and I just have one element in the vector because that's all I needed for this. And then let first v.iter nth of 0, I could have said next, and now I'm getting the type of first. So type of first is core option I32. So a nice way to just give yourself a sense of how these things work. Here's mutable, and now you see you return an itermute. The iterator is itermute. Okay, so I called itermute, and I'm getting out a mutable iterator, an iterator that allows mutation, and I get a mutable reference to that type. Here's into iterator, and I display it. So the type is into iterator I32, and you see me use it. So that's iterator and element types. Consequences of iterator types. This is getting a little long. I think I'm going to skip over that unless I hear some nays. Basically, what I'm doing is just showing you what happens where you mutate, where you mutate. What happens when you use an into iterator and you've consumed the type and so on. I'm showing you here also. Let me run it, and we'll just look at the output a little bit. Oh, yeah, and so here, if I had an iterator that returned values, I could ask it using the copies. I could say iter.copied, collect copies of that type into vec. What's really happening here is this iterator is returning a reference, and I don't want the reference, I want a copy, and this is a copy type, so it's just going to copy the value in. And I can do the same thing. There's a function called clone, and these two for a copy type do exactly the same thing. Okay, and now here I'm collecting derefs. So what this is showing you down here at the bottom, what this is showing you is what this iterator is really returning is a reference to the elements. And so if I tried to collect this directly into this vector, if I just said I32, it would say I have a type mismatch. But, and I'm showing you, things I can do. So here, by taking a copy of it, I just copy the contents of that reference into the collection. And here I copy a clone, which is the same thing for a copy type. And here I am dereferencing. I'm using a map function. So the iterator, we're going to talk about it in just a minute. The iterator has a bunch of functions. One of them is map. So what I say is map, and this takes a lambda, a closure, and I say take the reference to E and return contents of that reference. That's what I'm really doing here. I could have said E and contents of E and it would have worked the same way. And that lets me build vec of I32. If I just say, if I just pass on the reference, I've got to have a reference to vec32. And here I'm doing the opposite of what I did here. I'm just taking the. So this collect is a really nice thing. When you're iterating, a lot of times you want to, I've got a vector and I want to remove certain elements, or I want to take only the odd ones, or I want to do some operation on them. And I can collect results back into a vector just using this collect. That's what I'm doing here. And here, I just did the same thing using my functions, do iterator and do idiomatic. Nothing special going on here. You know, just shows that these functions can be useful. For example, you might want to build a comma-separated display. And so that means you got to monkey around with the first term. And you can do that in these functions. So it's just showing you how to do the same thing with functions. Now, this is something different. Hang on one second. Okay, good. So strings are something different. In Rust, strings are UTF-8, made up of UTF-8 characters. And that means that each character can be anywhere from 1 to 4 bytes. Okay? And so I can't index a string because of that, because the elements are not all the same size. So how would that work? It couldn't work with an index. So iterators take care of that for you. I'm going to tell you exactly how in a minute. If I iterated through the string and collected that into a vector of chars are not UTF-8. They are 4-byte hunks of memory. A char is a 4-byte hunk of memory. So what that means is it'll hold the largest of the UTF-8 characters, but it doesn't skinny down for the smaller characters. So if I copied a string into a vector of chars, I'd waste almost always 3/4 of the space would be empty. If the characters are mostly ASCII, it's going to be mostly empty. So anyway, here's how the Rust iterators tell the difference between these UTF-8 characters. If it's 1 byte, that byte starts with the 0 bits clear. Every ASCII character has a 0-bit clear. That's why you can represent ASCII in 7 bits. Okay? Because this top byte is always 0. 2 bytes have 2 bits set at the first byte. So now I got 2 bytes, and in the first one, the first 2 leading bits are set. So that tells me 2 to 2. 3 bytes, 3 bits are set in the first character. 4 bytes, 4 are set in the first character. If I have a trailing byte, it's not the first byte, maybe the second or third in a 4-byte sequence, maybe. All bytes that are not the first byte start with 1 0. So now you can tell exactly where you are. Am I at the boundary between characters? If not, I'll move on to the next one. So I could build, it would be really easy to build an iterator that iterates through this. And that's exactly what Rust did. So they have a iterator called chars, not iter, because Rust wants to make sure it's doing something different here. It's not returning the same size thing. So it's telling you this is different. So the name of the iterator is chars, and this is the iterator it returns. Okay? So, iter is a function that returns an iterator. Itermute is a function that returns an iterator. And here, chars is a function that returns an iterator. And this chars implements next self option char. So what's happened is he's always going to give you his results in 4 bytes. No matter whether that character was 1 byte or 3 bytes or whatever, he's going to give it to you in a char, which is 4 bytes. And that makes it really easy to collect into a vector if that's what you want to do. There's also something called Care Indices, another iterator, and that implements next itself and returns an option of size, use size, and care, meaning this is the count and this is the value of the character. If you're building a parser, you might want to know that information. I have this, you know me from class, I have this obsession with writing tokenizers. And so it's on my agenda to write a tokenizer in Rust. And guess what? Okay, I got to use these guys. So, and also they'll return bytes. So now this is just returning U8s. It's not characters. Okay, they're just U8s. If it's ASCII, they'll be ASCII characters. But if it has some non-ASCII characters in it, So let's do some iteration with strings. So here, for example, I'm iterating over, this is an emoji, so that's a 4-byte character. Cool. You can see I can do it. So, you know, this basic demonstration of the string iterators, here I am, here I'm just displaying the size of the char is 4. It's always 4. Iterating over a vector of characters, here I iterate over it, and then I put a space when I'm displaying it. So this is the way I'm displaying it. And now I'm iterating by reference over a string. So iterating by reference over the string, okay. And iterating over the string again. So I just went back and I iterated over the string again and got nothing, just to tell you that once you've used that iterator, you've used it up and you can't reset it. Which is okay, because you immediately turn around and just declare it again. You know, you wouldn't want to do that in a loop of that you're gonna wrap around 10,000 times or anything, but you know, most places it's just fine. Iterating over a string with Care Indices. So here I'm just displaying the item, and that's what this is. You know, 0A, 1 space, 2 S, 3 T, 3. You know, so on. And this one is oh, okay, I'll get to it. So I'm iterating over literal strings too, showing it works the same way. Both string and str give exactly, they both have char functions that return iterators. They both have Care Indices, function return iterators, and so on. Here I'm going to iterate over non-ASCII string. So here, so iterating over non-ASCII string, and I'm just displaying it and now I'm not putting any space between them. Okay, so I'm printing out a U, a P, a space, a U, a P, a space, and so on, a space, and now this is a single character, 4-byte character, that emoji. That's exactly what happened there. And now, just to be convincing, here I'm iterating over this non-ASCII string of bytes. I'm returning the byte form, and now remember that I'm not returning characters now. When I iterate over bytes, you know, I'm just returning bytes. So now let's look at this. all of these were ASCII 00000000 until the last one, which was 4 characters long. Okay, and sure enough, 1, 2, 3, 4, and then the stuff that tells me this. This tells me which emoji it is. Okay, that's how all that works. Piece of cake. A whole bunch of functions, tons of them, really nifty. Next, count, last, int, step by, skip, skip while, take, find. I've got some examples. We'll quickly, we're not going to dwell on them. We'll quickly take a peek at them. The one thing to notice is that some of these are consuming. Collect consumes the original thing you're iterating over because it's taking self. Filter does self. Map does self. But find doesn't. Find takes a reference to self, so it doesn't consume. Anytime you have a consume and you don't want it consumed, you can always map over a clone of the thing you want to iterate over, and so it'll consume the clone. It won't consume the thing you want. So a bunch of really useful things. If you remember from 687 that we talked about the standard template library, and they had iterators and lots of algorithms. Well, these are kind of comparable to the algorithms, and the iterators are a little nicer than the C++ iterators. Hush my mouth. They are. Okay. And so, there's a bunch of examples. Let me just run it mostly. We won't look at it, but, source collection. Here's my source collection, and I enumerate it. Here it just, basically enumerates, steps over it with a Care Indices. Here's the Care count, says it's 5. The last says it's 3. Nth of 3 is 2.5, 0, 1, 2, 3. Iter step by 2, 1 to 2 to 3. Iter skip 1 step by 2, skip 1, step 2, 1.5, 2.5. Here I'm doubling it using for each with a closure. For each is simply very like map with a collection. Okay. Take 4 map, iter find, iter filter. Here I am filtering out forgot. So here, so I'm filtering out. I'm just saying here, my closure is I'm taking E of type F6, and this has to be. It turns out it has to be a reference to a reference. My item is a reference, and as closure, this filter is expecting a reference. And I already have a reference to the, I'm returning a reference, so you got to write it this way. It looks a little weird, but you have to. So I'm less than 2, I'm greater than 2, and I'm less than 6. And sure enough, that's what I return, 3, 4, and 5. So that's the function, not every single one. So I don't have every single one on the... If you go to the documentation for Iterator, you'll find all these. When I go to more, here, this will show you functions I left out. I probably have 70% of them here. And here's the example. Quickly, just for loops. This came from the Rust documentation that says that this iterator sequence is what this for maps into. So, and here's standard iter into iter. So, this will work with either a iter or if I pass it something that's into iter, it'll work too. The for loop will work too. Ranges are cool. It's just something like start dot dot end. And if you'll notice on the range, if you declare a range, the start and the end are public. They wanted to make all of this. And so it's just, if start was 1 and end was 7, this always represents a sequence where it's closed on the low end and open on the high end. So it'll give you 1 in the sequence, but it stops at 6. It doesn't give you 7. And C++ does the same thing. And in the playground, we can see that I can do for on ranges, and I can use the adapters. Here's my range dot skip. I have to enclose it in parens, otherwise the compiler thinks I'm trying to apply dot skip to just the 7, and it'll tell me that I32 doesn't implement skip. So you got to close it in parens. So, and collect, so here collect works on the ranges. So here's just a range. So ranges are cool. And this is slices. So slices is like a range on steroids. I can take a slice out of a vector by saying my vector name is v. So I say reference to v, and this is what I want. And this says, I don't want the 0th element, I want the first element and everything that follows. So this is a slice that points to 2, 3, 4, and 5. And what a slice really is just a pointer, a reference to whatever the start is, and a length. Rust refers to it as a fat pointer. They say a slice is a fat pointer, meaning it's a reference to the start item with a length, bundled up into the same thing. Here I have an array of literal strings. So here I'm just declaring that array of literal strings, and I can create a slice just by making a reference to that. So I say slice, and if I said dot dot, that would take all of them. This is taking everything. It takes the 0th one, the first one, and the second one. And byte array, I can, create this creates a byte array slice that takes the whole array. And I can use slices with for loops. So here I'm just taking slices and showing you what they look like. But the point I wanted to make is here that this works fine with for loops, for item and b slice. Just like you can put a range in a for loop, you can put a slice in a for loop. Think of a slice as a non-owning view into some collection. When that slice goes out of scope, nothing happens to those values. It doesn't own them. It's just a reference. Okay. Now, one thing I want you to notice here is, here I have a slice of a byte array that's 0. So here's my byte array. Whoops. No, here's my byte array, 0, 1, 2, 3, 4. Now I create a slice of that byte array that starts at the second element, 0, 1, 2. It starts right here. And now I say b slice 0 is 42. Look what happened. 0, 1. It inserted 42 at the beginning of the slice. Not the beginning of the array. So what that means is that you can do bit fiddling really in a really slick, easy way. I built a message class that was manipulating bytes to store stuff. for a message passing communication system I wrote in Rust a little while ago, and I did it just this way. So you can get here and manipulate bits all you want. Okay, and there's some references, so we went over this fairly quickly. You're going to want to go and tomorrow morning with a cup of coffee, sit down and go slowly through the playground code, and look back in the presentation. And if you have any questions you can't resolve by doing that, just ask them on Discord. I'll be happy to answer. Okay, one last thing I want to do before we go. So I want to go and talk a little bit about writing idiomatic Rust. We've already talked a little bit about that when I ran Clippy. Here's a little example of something I'm improving, making this code a little more idiomatic. This is the idiomatic code. This is the code that isn't so idiomatic. What's happening here is I have an option. I'm just using the demo one. I'm not using the other, but just for illustration. If demo one is sum, if I have a full option, then display what the option contained and unwrap it. To get the value there, you got to unwrap it. Otherwise, my option is none. Now, you want to avoid these unwrapped statements. Just not idiomatic code. You look at good Rust code, you almost never see an unwrap. I gotta say, in the Rust book, where they were teaching you Rust, they got unwraps all over the place, and they were doing that because it was quick and easy for their short little demos. But if you look at good Rust code, you won't see unwraps all over the place. Here's what you do. Same problem. Demo 1, demo 2. If let sum ref s equals demo 1. What this if let statement does, this is a matching statement. It's an if statement, but when I do this let inside the if let sum, this is not an assignment. I'm matching demo 1 against sum ref. Is demo 1 sum of something? I added this ref so that I get a reference to s, not the value of s, because I don't want to consume demo 1. If I don't have this ref here, I'll consume demo 1. But I didn't want to consume it, and so I'm using ref 1 here. And now this statement implicitly does the unwrapping. If it succeeds, if it is sum, it unwraps it for you. You never say that. And so you just print it. Otherwise, display as none. A little cleaner, a little nicer. Okay, so. And here, if you're not careful, you can get and notice that I'm not binding. There's no way to bind. Here, I'm binding this S. I'm creating this. This is a binding being created right here. S didn't exist before this statement. Now I'm binding to S, and now I can use it. I just print it right here. Once I've done this dereference, I can use it. So a little more idiomatic, and this is a playground demo for that. So Clippy tool is a good way for checking your idiomatic code. So somebody have a question? Nope. Okay, so here's let mute iter equal v iter, let sum equal iter nth equals 0. Okay, I did this example when I saw what Clippy did with me with my command line parser. So I just displayed this, and here's the warning, if sum iter nth, try calling next instead of nth 0. Telling me how to fix it. Way to go. Just like the compiler. And here, if I want to suppress it, it's telling me, here's, you got this because you have warn Clippy : iter nth 0. If I want to turn it off, I just say at the top of my code, pound colon, pound exclamation mark, bracket, allow, blah. If I put this at the top of my code, normally these statements only apply to the next thing coming. But if you put a exclamation mark between the pound and the bracket, you can put it at the top of your code and it applies to your whole file. So that's what I normally do. And there's a playground demo that just illustrates that's not doing what I think I have. This is a bug in my presentation. Nooper, do me a favor. And when this is over, go to Discord and remind me that in idiomatic Rust, in the Clippy section, I have the wrong code in Playground Demo. Okay, thanks. Now this Clippy lint, this is a list of all the Clippy lints, and notice that they have correctness lints, restrictive lints, style lints, deprecated lints, pedantic, complexity, performance, cargo. No. So if you're worried that you're writing code that's too complex, you can get rid of all these. Except complexity. And what he's saying is, oh no, sorry. This lint just applies to this example, but here we'll look at that and we'll see that down here. So Clippy lints has divided its rules. So the lints are just rules about what it will warn about. So just using Clippy, everything that has no false positives. So if a lint is known to return some false positives sometimes, it won't be included in Clippy. Clippy pedantic gives you everything. So if you use pedantic, you got to be aware that, hey, sometimes I'm going to get a false positive. Nursery says, these are new lints and we don't know whether they work yet or not. So you probably don't want to use them. Style, this is stuff you could write it in a more idiomatic way. Complexity, code does something simple but in a complicated way. And here, this is a great thing as you're beginning to learn to use Rust. This is a great one to look at. Performance, code that can be written in a faster way. So, Nikhail, this really gets at your point. You can check cargo. I've never done that. I don't really know. I haven't looked at that. Clippy correctness, code that is just outright wrong or very, very useless. It'll tell you about that. Okay. So good for you, Clippy. So Clippy is a wonderful tool. I use it a lot, and you should too. I should have, at the very beginning of my bytes and the beginning of my Rust story, I should have said, whatever you do, run Clippy on most things you write. But I didn't think to do that. Clippy links. There's also a set of Rust API guidelines that talk about, naming conventions, interoperability. This is an ebook, okay, and you can just click on it. But it's not as easy to use as Clippy, because Clippy you just run it and it natters at you, tells you about these things. But here you'll find that it gives you a little more explanation. It goes a little deeper into what the problem is. So when you get Clippy area, if you don't understand what Clippy is trying to tell you, you might go to these Rust API guidelines and look at them. They're pretty large. There's a lot of stuff here. And so this isn't something you're going to sit down with after dinner and read in an hour or something, you know. But shortly, once we're done with this BuildOn set of sessions, I'm going to go back through my site and just clean up some stuff, some of the stuff I wrote a long time ago, and I'm planning on using these guidelines to help me make all my examples really as clear and plain and simple as possible. You know, so my intent is to go one more step in my own learning of Rust by being very careful at, you know, looking at what the documentation says. You won't always agree with it. There's things that I don't agree with, and that's okay. But anyway. So final thoughts. So most difficult part of writing idiomatic Rust code is to use the Rust language and libraries rather than building your own facilities, whenever that's practical. The community, there's a really nice, if you go to users.rust.lang.org, I think it is, there's a user forum, really nice, very nice, you know, they go out of their way not to be harshly critical. They'll answer your questions, even very basic questions they'll answer. But they get a little impatient. You can tell they're nice, you know, but they're impatiently nice when you start showing them code that is a complicated way of doing something that a Rust facility had, you know, really nicely, just simple one line, bang, there it is, and you've written 7 lines of code. Okay, they push you rather vigorously. You know, go look at that part of the documentation. So that's the hard part. Yeah, how do you do that? How do you there's lots of facilities. How do you figure out, you know, what's there? And the question is, Clippy is of help. It does. It helps you. But you need to read the language and library documentation, and it's really nice, you know. Let me just do this. Rust mutex. So here's the documentation for mutex, and I can go to the source code and I can look at it, loaded with comments, you know, and they're telling you about stuff, you know, what does poison mean, what am I doing, blah 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 blah. They're all using, you know, really nice idiomatic styles. So looking at the source code, I'm not suggesting you just go and look at the source code for fun and profit, but what I am suggesting is that when you want to know, you know, you want to know a little more about how iterators work. I looked at the documentation a lot. When you're there in the documentation, go take a couple of minutes and look at some of the source code. It's not really bizarre, you know. It's really, you know, straightforward. This week in Rust is something you want to know about. I really like it. I look at it all the time. This week in Rust 283, I've got some stuff I'm looking at right now, you know, looking back at asynchronous Rust. Rust is an app language. How often does Rust change? Serving a single file over HTTP with Rust. How to execute shellcodes from memory in Rust, you know. Beginner's Guide to Rust Match History. Just tons of stuff. So really nice. I subscribe to it. It comes every Thursday. I get one of these, and I look at it. I read it all. Well, I don't read it all. I mean, I read all the interesting stuff. So. And there's a book I like, you know. There's lots of free ebooks, and you say, why on earth would I do that? And the reason you would is that this is just super. You know, not cheap, $50. But it's much better than the Rust book, much better than Rust by Example. It's written by guys who worked on the Rust development team and has lots of interesting diagrams and, really thoughtful. They don't waste your time. They march right into stuff, but um, I think that's $50 very well spent. If you're interested in really learning Rust, I own a copy. Mike owns a copy. Good. By far the best Rust book I know of. I think the best resources for learning Rust are this book, my Rust Bites, and my Rust Story. Okay. I'm a little biased, of course, right? Pat myself on the back. But, that's what I believe. I believe that. Okay. I've looked at a lot of stuff. So anyway, are there any questions? I'm pretty much done for the day. We talked for an hour and a half. We talked for almost 2 hours. Oh my gosh, that's too long. I have one question for you. And that I'm kind of debating on what, if anything, I want to do after this one. We have a couple of extensions that I want to do. Using threads in the text search and using regular expressions. But once those are done, shall we pick another project and work on that? Or I was thinking of doing something like Rust Probe of the Week, where I just pick something that I think is kind of interesting and not hard, but not obvious either. And I'll pose, try to do this thing. And then the next week, I'll provide the solution and I'll provide a next probe. Would that be useful?
I think so, Doc. I think that's a great model.
Yeah, that will be fun as well.
Yeah, I would probably do one, not both, either another Rust project after TextFinder or the Rust of the Week, because I got other stuff I'm, itching to get at. I haven't done any WebAssembly with Rust yet, and I'm really itching to do that. And
yeah, Doc, what comes to mind is it's almost a variation on like a brown bag kind of thing, where this week it's WebAssembly, and people are going to get, this has been pretty good to get most of us up to that point where we're aware and we go and develop some of the skill sets independently. But now if you start to bring some of those, maybe it's an advanced topic, maybe some week it's really about an interesting use of threads in context, or the next time it's about WebAssembly or those aspects that you have to go off and get on your own that are complex all of themselves,
Okay. I like that idea, Mike. Why don't you just make a quick note on Discord for me so I don't forget it?
Okay.
Just might do that. You other guys, if you would prefer to do another project, let me know. But if that Rust Probe of the Week sounds interesting to you, if it gets complicated, like WebAssembly, I couldn't turn around next week and do a probe on WebAssembly. I don't know enough. Okay. And I need to, macros is another thing. I need to get some practice with macros. So, it might be probe of every 2 weeks for a while, but my mental model would be a probe a week. But
Okay.
and then so I would plan on doing no more than half an hour, absolute max. Short tapes, short disclosure. So the bit is small enough so that we can talk about it in half an hour, have a half an hour tape, and so it's quick and easy for people to. Make sense? All righty. I'll welcome your feedback. If you want to give me any additional feedback on Discord, that would be super. I'm delighted to have all you super guys here. I love to see my former students. It's been too long. I always enjoyed being in the classroom. It was a pleasure for me to walk into the room and see, 50 or 100 faces looking at me. It was, I really enjoyed that. And more than anything else, I enjoyed interacting with you guys in the hallway. The Friday morning help sessions were, I couldn't wait for Friday morning to come along. I know you guys could wait, but, but I really enjoyed doing that. So, this is a nice substitute for that. So, all righty. If there's no additional comments or questions, we will call it a day, and I will say sayonara. We ready to say goodbye?
Thank you.
All
Thanks,
righty.
Doc.
See you guys.
Thanks,
Dr.
Professor.
Parse.